Welcome to Physics Laboratory. In this module, we're going to learn Wheatstone Bridge. Here is the outline of our practicum: objective, theory, tools, practicum procedure, and data processing. First outline: objective. The model contains 4 objectives to be achieved by the end of the practicum. 1. To understand the principle and be able to set up the Wheatstone bridge. 2. To be able to know how to measure the resistance of resistor using Wheatstone bridge, multimeter, and read the resistor pen color. Second outline, theory. First, theory about resistance. The resistance value R represents the characteristic of a conductor or electrical components that points to the ease or the difficulty to conduct the electric current. Higher resistance value means fewer current flows and vice versa. There are several methods for measuring the resistance value. First is identify the each bands of the resistor, and then using ohmmeter, using Wheatstone bridge, and using amperemeter and voltmeter simultaneously. But in this module, will not use the fourth method. Second theory about the principle of Wheatstone bridge. The Wheatstone bridge principle is based on the circuit in the picture. Some part of current I that come from point A pass through R1 and the rest through RB. If there is a potential difference between point C and D, the current will flow through galvanometer G, and as the result, its needle would divide. In fact, we could try to make the potential difference between point C and D to be same by changing the value of R1 and R2. If this is achieved, there is no current through G and the galvanometer needle does not experience deviation. So the bridge is in a balanced state. If there was no current flowing through G, then the amount of current flowing through R1 and R2 would be the same, like we can see at the point I1. Since the potential on point C and D is same, then VAC equal VAD and VCB equal VDB. Third outline, tools. In this practicum, we're going to need 8 tools. The first one is DC power supply. Second, galvanometer. 3. Resistance gate box with variable resistor. 4. Wire with shear contact. 5. Lead socket. 6 is 3 identical resistor with unknown value. 7. Multimeter and 8. Jumper.
Hello everyone, we will start our practicum today. Today, we are going to learn about Wheatstone bridge. In this module, we are going to need several tools. First is a lattice socket. Second is resistor 47 kilo ohms and 3 identical resistors, unknown value. Jumper, resistance gate box, galvanometer, multimeter, and wire with shear contact. When wire with shear contact is installed, it will become Wheatstone Bridge. In this module, we have two objectives. One, to understand the principles and be able to set up the Wheatstone Bridge. Two, to be able to know how to measure the resistance of resistor using Wheatstone Bridge, multimeter, and read resistor band color. Our first experiment using a multimeter. Then we calculate three identical resistors. We set the top limit of the multimeter to 20 kilo ohms. Then we put the resistor to multimeter. Resistor X value is 2.17 kilo ohms. Then for resistor Y, value is 3.35 kilo ohms. For resistor Z, value is 0.45 kilo ohms. Our second experiment using band color. Every resistor has color band. Usually, every resistor has 4 color band. For resistors that have 4 color band, first and second color band is first digit and second digit. Third color band is multiple number, and fourth color band is percentage value of resistor's tolerance. For example, is the resistor color band is red, 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 and gold. So if red color band value is 3, then resistor value is 3, 3 for first and second digit. If red color band value for multiplier number is 1000, then the resistor value is 3, 3 multiply 1000. So the value is 3300 kilo ohms. Last color band is gold if gold value is 5%. So resistor color band value is 3300 kilo ohms plus or minus 5%. Now I will mention the color band of each resistor, and please find the result of each resistor. For value of each color band, you can see in the module. For resistor X, the color band is red, 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 gold. One more time, red, 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 gold. For resistor Y, the color band is orange, orange, red, gold. One more time, orange, orange, red, gold. For resistor Z, the color band is yellow, purple, brown, gold. One more time, yellow, purple, brown, gold. Please find the result of each resistor. Our third experiment using Wheatstone bridge. In this experiment, we are going to need several tools. For resistor X, when we measure with multimeter, the value is around 3300. So, the variable resistor in Wheatstone bridge is setting in 3000 to approaching the resistor X value. So, when we look for the distance is not too far from the galvanometer. The experiment step is: first, we look for a place on the Wheatstone bridge that has a current of 0. Zero current is in the 53 because the Wheatstone bridge has scale 0 to 100. So remember the R1 is 53 and R2 is 100 minus 53 equals 47. One more time, R1 is 53 and R2 is 47 and resistor variable is 3000 ohms. Next, resistor Y. Resistor Y value is around 2000, so the variable resistor in Wheatstone bridge is setting in 2000. We start to searching current 0. Zero current for resistor Y in the 32. So R1 is 32 and R2 is 100 minus 32 equals 68. And variable resistor is 2000 ohms. One more time. R1 is 32, R2 is 68, and variable resistor is 2000 ohms. And then resistor Z. Resistor Z value is around 400. So the variable resistor in Wheatstone bridge is setting in 500. We start to searching current 0. Zero current for resistor Z in the 44.5. So R1 is 44.5 and R2 is 55.5. And variable resistor is 500 ohms. One more time, R1 is 44.5, R2 is 55.5, and variable resistor is 500 ohms. We have finished running Wheatstone Bridge practicum. Thank you for watching.